So the second unit is on exponents and exponent laws, and then we go on to financial math. And the reason why those two are in the same unit is because they're closely related. All of the equations we use when we're determining how much to pay back for a loan or how much an investment will earn, they all relate back to exponential relations and the use of exponent laws. So the first thing we're going to do is we're going to start with exponent laws. And before we do that, I'd like to focus on this section here in this minds on section where we have the base, the power, and the exponent. So what you're seeing here is basically this is what an exponent is. So for an exponent, we have some terms we need to understand. So the entire number and the exponent itself is called a power. The larger number is called the base, and the smaller number is called the exponent. So when I refer to each of these, you need to understand the difference of the words that I'm using and what they mean. And really why we use exponents is because it's easier than writing a repeated multiplication, as we see over here. The number, or the expression 3 times 3 times 3 times 3 takes up a lot of physical space on a paper, so it's easier to just write 3 to the power of 4. And when we write exponents, we can find some properties between them that help us simplify things down into easier to complete mathematics. So we're going to use that information to generate what we call the exponent laws. And the first of which is the exponent law of products of powers. So a product refers to multiplying two powers together. So here I have, in general, I have x to the power of a times x to the power of b, and that would equal x to the power of a plus b. So if I'm multiplying two powers together, it's equivalent to adding the exponents together and creating a new power with the same base, and the exponent of that power being the sum of the original two exponents. So notice this only works if I have the same base as well. So I have xa, xb. If I had xa, yb, I can't combine those together. Those are two different bases, so I can't combine them together. So these exponent laws only work when we have the same x, in this case, base. And when we don't have the same base, we can't use these exponent laws. So again, the first one is right here. It's called the exponent law of the product of powers. Product means multiplying. So here's a power 1, here's power 2. We're multiplying them together. That's equivalent to adding the exponents and creating a new power with that sum being the exponent. Next, we're going to look at what happens when we divide exponents. So here, if I have x to the power of b divided by x to the power of a, it's equivalent to subtracting the exponents. So this is called the exponent law of division, and it really occurs because if we are dividing, as you see in this example here, if I have 3 to the power of 5 divided by 3 to the power of 3, it would look like this if I expanded that. And for every 3 in the denominator, I can get rid of a 3 in the numerator. So these 3 3's, in this case, can divide these 3 3's, and the division of those is 1. So this becomes 3 times 3 times 1, or just 3 times 3, or 3 to the power of 2. So this is our exponent law for the quotient of powers, or the exponent law of division. And the other exponent law we're going to look at here is the power of a power exponent law. So what the power of a power means is, let's say I have an exponent like 5 to the power of 3, and let's say I have a power 5 to the power of 3, and I raise it to an exponent. Well, this is our base power of 5 to the power of 3, but this is our other power here, 5 to the power of 3 to the power of 4. In this case, I can multiply the two powers, or the two exponents together, and get a new power with the exponent being the product of the two original exponents. And you can see how this occurs. Here it's 5 times 5 times 5. I repeat that 4 times. And if I do 3 times the 4, I'll have 12 5s altogether. So there's two other properties that we'll need to know. And these would be the what happens if we have an exponent of 0, and what happens when we have a negative exponent. And to figure out how these are calculated, what I'm showing you here are two tables that demonstrate another way of kind of thinking of exponents. So if we have, let's take our base of 4, and let's increase our exponent. Let's increase it by 1 each time. And what we would have on a table of values like this is essentially we would be multiplying by 4 every time we move down a step. So using that same idea, we can go backwards by doing the inverse operation. So we can divide by 4. So 4,096 divided by 4 is 1,024. Divide that by 4, we get 256. Divide that by 4, we get 64. And then we can get 16, and then 4. If we keep going backwards, we would have our exponent here, which is 1, decrement each time. So 1 becomes 0, then -1, then -2, then -3. So if we go backwards by this dividing by 4, we can see that the exponent, when the exponent is 0, we have what's called a null multiplier. We have the value of 1. And this occurs for any power where the exponent is 0. The answer will be 1. And then when we go further back, we divide by 4. So that 1 divided by 4 gives us 1 over 4, then 1 over 16, then 1 over 256. And you'll notice that this is equivalent to, oops, sorry, it should be 1 over 64. There was a mistake there. This is equivalent to what the power is here. So if 4 to the power of 2 is 16. So this is 1 over 16. 4 to the power of 1 is 4. So this is 1 over 4. So this is our law of, this is our law of exponents. Our exponent law when we have an exponent of 1. And, exponent raised to the power of 0. So that's x to the power of 0 equals 1. And then when an exponent is raised to the power of a negative, I'm not sure why this isn't selecting anymore, we would have this law here. X to the negative a is the same as 1 over x to the power of a. So there are some sample questions here. I won't go through these too much. I'm going to spend some time working on the support questions just so that you have some more samples to work with. But the general idea of applying these or completing these questions is first you would simplify the expression down to a single power, and then you would evaluate it if you're asked to evaluate. So simplify the expression means you basically go to this step. Evaluate means you would write this step. Let's look at some of these questions here, and we'll complete a few. So simplify each expression into a single power, and then evaluate. So let me open up my camera. For the first one, it says to simplify, let's do 1a. we have 8 to the power of 3, and it's multiplied by 8 to the power of 3. So simplifying this gets us 8 to the power of 3 plus 3, or 8 to the power of 6. And then the evaluating part you would do on a calculator. 8 to the power of 6 is 262,144. Let me try, I'll do 1D. 9 to the 5 times 9 to the 2. Here I'm adding the two together, 5 plus 2, 9 to the 7, and then 9 to the power of 7 is 4,782,969. Let's try some of the ones under question 2. So I'll do 2B. This is 6 to the 7 divided by 6 to the 2. Here it's the same as subtracting. 6 to the power of 5. So 6 to the power of 5 gets me to 7,776. And to C, I have 5 to the power of 9 divided by 5 to the power of 4. This is the same as subtracting. 5 to the power of 9 minus 4. 5 to the power of 5. And 5 to the power of 5 is 3,125. I'll do one of these power to a power questions. So we'll do 3A. 3 to the power of 7 to the power of 2 is the same as 3 to the power of 7 times 2, which is the same as 3 to the power of 14. So this is going to be a very big number. 3 to the power of 14 gets me 4,782,969. Same answer for 1D, actually. And now let's look at some of the more difficult ones here, the ones that involve zero exponents and negative exponents. So I'll do 4C, and I'm going to do 4G. So for 4A, I have 12 to the power of 2 to the power of 0. Well, in this case, it would be the same as 12 to the power of 2 multiplied by 0, which is the same as 12 to the power of 0, which is always 1. For 4C, I have 2 to the negative 5 times 2 to the power of 3. In this case, it's 2 to the negative 5 plus 3, which is 2 to the power of negative 2, which I would express this as a fraction, which would be 2 to the power of 1 over 2 to the power of 2, which is 1 over 4. You would not express that as a decimal. For this one, it's fine because it's a terminating decimal, but in general, I want you to express those as fractions. Now this next one is a fraction to start with. 3 to the power of 2 to the power of 3. So in this case, I have 3 over 4 to the power of 2 times 3, 3 to the 4 to the power of 6, and this 6 gets applied to both in the numerator and the denominator. So 3 to the power of 6 over 4 to the power of 6. And I'll need to calculate these. 3 to the power of 6 is 729, where 4 to the power of 6 is 4,096. So now let me go to the, let me show you what our quiz will look like for this unit. So I'm going to pull up the quiz here. Give me a quick second here because I need to get it to show up on the screen. So here's the exponent laws quiz. So you'll have 12 questions, and they're just going to be like this here. 2 to the power of 4 times 2 to the power of 3. So you'll have 2 where they are products, 2 where they are quotients, so division, and 2 where they are powers of powers. And then you're going to have somewhere that's going to mix up, and I want you to show a little bit extra work. So what I'm going to do here is, for the first few, you will be, let's see here if I do this. Okay, so I'm just going to move this over to the side so that I can see my calculator. So for the first few, you'll be solving these by using your calculator and writing down the answer. So 2 to the power of 4 times 2 to the power of 3 is the same as 2 to the power of 4 plus 3, which is 2 to the power of 7. So 2 to the power of 7 is 128. So I can write my answer as 128 for this question. Let's try one where we have division. 4 to the power of 5 divided by 4 to the power of negative 6 is the same as 4 to the power of 5 minus negative 6, which is 4 to the power of 11. So 4 to the power of 11 is 4194, 304. And let's try another one here. 2 to the power of negative 4 to the power of negative 2. So negative 4 times negative 2 is 8. So this is the same as 2 to the power of 8, which is 256. Now for these questions 7, 8, 9, 10, 11, and 12, it says express your answer as a whole number or fraction, take a picture of your work, and submit that picture to your teacher. So what I want you to do for these questions is to do these on paper. So I will open up my video capture device here, and I'm going to reduce the size of that for a bit.
Good
morning. So we have, sorry, my video capture device is off. There it is. So in this case, it's 4 to the power of negative 6 times 4 to the power of negative 3. So if I want to show this, I will be adding these two, negative 6 plus negative 3. So I end up with 4 to the power of negative 9. And then to show that as a fraction, I'll have to determine what is 4 to the power of 9, which is, it's going to be a pretty big number. So I'll write that 1 over 262,144. This here is the picture I'll have to send along with my test. So I'll try one more of those. We'll do this one, number 10. And then we will we'll call it the end of this video. So 3 to the power of negative 2 divided by 3 to the power of negative 4 is the same as 3 to the power of negative 2 minus negative 4, which is the same as 3 to the power of, well, in this case it's going to be positive, so 3 to the power of 2. And this is just 9. So you'll have to show that, take a picture of that, and submit that as your answer.